section 7.1, operations on functions. So a lot of what we're going to do in this section is dealing with function notation. We are going to add, subtract, multiply, and divide functions, as well as figure composition of functions, putting one function into another. It's very similar to things that we did in the last chapter. So we're going to utilize a lot of those rules on simplifying polynomials here in this lesson today. Okay, so on your notes handout, we'll start with that table there. We are going to again be adding, subtracting, multiplying, and dividing functions, and this table is just showing you what they mean. So if we're adding two functions, it's going to look like this. It would say f plus g of x. What that means is we're going to take our f function plus our g function. Let's start with an example where we're adding two functions. Look at letter A with me. In letter A, we have 3x squared plus 7x. That's our f function. And our g function is 2x squared minus x plus 1. So I want to take f plus g of x. That simply means I'm going to take my f function, I'm going to add it to my g function. The expression that is representing our f function is 3x squared plus 7x. So 3x squared plus 7x. Plus our g of x function. This is our g of x. Okay, Wyatt, here's a note for you. Our g of x function is 2x squared minus x minus 1. We are simply just adding those two functions together. There are two polynomials that we're adding. Add your like terms. So 3x squared plus 2x squared is 5x squared. I'm going to cross them off as I use them just to show that I don't have them anymore. 7x minus x is 6x, and then my constant minus 1. Okay. None of those are like terms, don't go any further. So that's what I mean when I say f plus g of x. I'm simply just adding the two parts of the function. Go back to that table on top. Let's look at one with subtraction. It'll say subtraction like this, f minus g of x. It means we're going to take our f function, we're going to subtract from it our g function. So if you look at the next example, this should be letter B on your notes handout. Again, f of x is 3x squared plus 7x, and g of x is 2x squared minus x minus 1. We are calculating f minus g of x. So our f function that is given is again 3x squared plus 7x minus our g function, 2x squared minus x minus 1. Now I've done something that is incorrect. Does anybody know what I should do? Parentheses, that's correct. Because we're subtracting that whole function, aren't we? So I need parentheses around my g function. I have to put them there because what do I need to distribute? The negative 1. Please go ahead and do that. We'll bring down the 3x squared plus 7x, and then I'll distribute my negative 1. Negative 1 times 2x squared, and negative 1 times negative x, negative 1 times negative 1. Make sure if you're subtracting that second polynomial, that second function, that you do distribute your negative 1. Now let's add our like terms. We have 3x squared minus 2x squared, which is x squared. 7x plus x is 8x, and then plus 1. So far, is it much different than what we've been doing? No. Polynomials? No. Just the notation is different. Go back to that table. Let's look at one where we are multiplying. We'll know we're multiplying because it will say f times g of x. We're going to take our f function and multiply it by our g function. So let's look at example E. I'm going to jump down to letter E. In letter E, we have f of x equals 3x squared minus 2x plus 1. And g of x is x minus 4. So we're taking f of x times g of x. I'm going to use parentheses here because I am going to have to multiply. 3x squared minus 2x plus 1. And I'm taking f of x times g of x, which is x minus 4. How do we multiply two polynomials?
Multiply the big number and add the exponents.
We're going to have to distribute. Yes, you're right. Let's take 3x squared times x. That'll be 3x to the third. 3x squared times negative 4. Negative 12x squared. Next we'll distribute our negative 2. X. Negative 2x times x.
Negative 2x squared.
Negative 2x squared. Negative 2x times negative 4.
Positive 8x.
Positive 8x. Next we'll distribute our 1. 1 times x. And 1 times negative 4.
Negative 4.
Now we'll add any like terms. I don't see any other x cubes, so I'll bring down that 3x cubed. I've got x squareds there, so negative 12x squared minus 2x squared is negative 14x squared. 8x plus x is 9x. And then minus 4. Now the division of polynomials is slightly different than what we've talked about before. Come back up here to this table with me. If it has f divided by g of x, it simply means f of x divided by g of x. In addition to writing our division expression, we are going to have to tell the value of x that will make our denominator 0. Okay. Let me show you what I mean. On your notes page, let's look at example F. So here we're using the same two functions that we did in letter E. We're taking f divided by g of x. Okay. So our f function is here. Let's go ahead and write that. 3x squared minus 2x plus 1. And we're dividing that by our g function, which is x minus 4. Okay, so far I have f of x divided by g of x. Haven't done anything beyond this. Last chapter we did long division and synthetic division to divide a polynomial. You do not need to do that here. You can stop. This is all I need. Okay. As far as simplifying, I don't do any further. But what I do need you to tell me is the value of x that would make our denominator 0. Going back up for a second. If I had x to be 4, if x was 4, it would be 4 minus 4, that would make it 0 in the denominator, wouldn't it? Can we ever have 0 in the denominator of a fraction? No, it's undefined. So part of writing a rational expression is telling me the value of x that will make that denominator 0. And I don't want to say x equals 0, I want to say x does not equal 4, sorry, not 0. X does not equal 4. So put your slash through that equal sign, please. Now, how can you get this answer? I hope you can look at this problem and say that, well, if x is 4, the denominator is going to be 0. There might be more complicated than that. All you have to do is simply set your denominator equal to 0 and solve that equation. When is my denominator equal to 0? I solve that equation, and when x is 4, my denominator will equal to 0. This is what I would need for division. Let's look at another division. I think there's one more on letter H. So on this one, if we set up our division, we're going to use f of x divided by g of x. So f of x is 2x squared plus 3x minus 1 divided by g of x, which is x plus 2. I don't need you to further simplify that fraction, that division, that's all you need to do. but I do want you to tell me the value of x that would make the denominator 0. Can you look at this and tell me? What should x not be? Negative 2. Just put a comma and I'll say that x should not equal negative 2. And again, if you're not sure how to get that, just set your denominator equal to 0 and solve. Any questions so far on adding, subtracting, multiplying, or dividing? Okay, the other thing we need to talk about is composition of functions. So flip over to the back side if you would. Okay, I'm going to use pineapple pizza to help you understand compositions. So, f of x. Pretend f of x is a pizza. F of x is a pizza, and g of x is a pineapple. Okay, f of x is a pizza, g of x is a pineapple. So this right here means f of g of x. What that means is I'm going to take my g of x and I'm going to put it into the f function. I'm going to take my pineapple and I'm going to put it into the pizza, which gives me pineapple pizza, right? This reads g of f of x. What this means is I'm going to take my f function, I'm going to put it into my g function. So this time I'm going to take my pizza and I'm going to put it into the pineapple. That's what we get here, the pizza into the pineapple. You see it? Okay, that's what we're going to do, but with algebra. Pineapple pizza is my favorite. You guys like pineapple pizza?
Oh, it's unfolding.
If you've never had it, you're missing out. You should try it next time. Okay, so let's start with notation. How are we going to write this? On the top of your page, do you see this right here? Let's write down what this is meaning. This is just notation. You just need to understand what this is telling you. I first want to put it into words what this says. This I would read as F composite G, not fog. Okay? Don't say fog. That circle right there means composite. It simply means I'm going to take my G function and I'm going to put it into the F function. So when you see F composite G written like this, again, it means I'm going to take my G function and I'm going to put that G function into the F function. You read it backwards. G composite F of X. Again, that circle there means composite. This means I'm going to take my F function and I'm going to put it into my G function. I'm going to take my F function and I'll put it into the G function. It's important that you can separate the two and you can understand what F composite G means and G composite F means. We're taking our G function here and putting it into F. And here we're taking our F function and we're putting it into the G function. We did this last chapter. We just wrote it a little bit different. We did this. Let's look at a couple of examples. Let's look at A. No. This is your A, right? Yes. All right. So here they're asking us to find two things, F composite G and G composite F. F of x is 2x minus 5 and G of x is 4x. So on your notebook paper or on your notes page, I want you to start with F composite G. And we're going to have to label this. Otherwise we won't know which is which. You have to label. So let's write this down. F composite G of x. Remember, this means I'm going to take my G function and I'm going to put that G function into the F function. We're working our inside out. We're taking our G function and putting it into the F. So our g function is 4x. Please circle 4x. We are going to put 4x where? We're putting it in 4f. So we're going to put 4x in 4x right there. So it's going to look like this. F of, putting 4x into that function. So I'm taking out x, and in x's place, what am I putting? 4x. So 2 times 4x minus 5. Okay? I'm putting the pineapple into the pizza right here. Just simplify. Just simplify. 2 times 4x is 8x minus 5. Those aren't like terms, so stop there. It's very important that you're labeling your work as f composite g of x. I need to make sure that you know this answer is at 8x minus 5. Let's go the other direction. Now let's do g composite f of x. G composite f of x means I'm taking what function? Taking f and I'm putting it into g. So we take our f function, we're going to put that function into g. So I'm going to come back here to the top. I'm going to change colors. I would like for you to circle your f function, that 2x minus 5. Okay, so where are we going to put 2x minus 5? Into our g function. So I'm going to put it into right there where that x is. So it's 4 times 2x minus 5. I took out x, and in x's place I'm putting that f function, 2x minus 5. Now simplify. 4 times 2x is 8x, and 4 times negative 5 is negative 20. Let's try another one. On letter B there, I do know there's a typo. On that f function, that should be 3x squared minus x plus 4. Would you go ahead and change that on letter B? On the f function, that should read 3x squared minus x plus 4. The g of x function is 2x minus 1. So they're asking us to find two things here. Let's start with f composite g. So in your, or on your notes page, go ahead and write down f composite g of x. This means I'm going to take the g function, I'm going to put it into the f function. So my g function is 2x minus 1. Go ahead and circle 2x minus 1. I'm going to replace the x's in that f function with 2x minus 1. I'm putting 2x minus 1 in for x there, and put it in for x there. So f of 2x minus 1. So into my f function, I put my g function. Okay? I replace g of x with 2x minus 1. So I've got 3 parentheses, 2x minus 1 squared minus 2x minus 1 plus 4. Okay, so we've got a lot of work to do to simplify this. I have a binomial squared. What do I have to do here for binomial squared? I have to FOIL. I'm going to bring my work over here. I need more room. So I've got my 3 still. When I FOIL 2x minus 1 times 2x minus 1, I'm going to get 4x squared minus 2x plus 1. Go ahead and distribute my negative 1 here. So I have negative 2x plus 1 and then plus 4. Keep going. I'm going to go ahead and distribute my 3. I could add like terms if I wanted. I've got 12x squared minus 6x minus 6x plus 3 minus 2x plus 1 plus 4. Now add your like terms. We don't have any other x squareds, but I've got a few linear terms. Negative 6x minus 6x is negative 12x. Negative 12 minus 2 is negative 14x. And then 3 plus 1 plus 4 should be 8. Okay. That one's a lengthier problem. They won't all be that long. Okay. But anytime you have a binomial squared, you're going to have a longer problem. We need to go the other way. We need to do g composite f of x. G composite f means that I'm going to take my f function, and I'm going to put that f function into g. This one will be a little bit nicer. I'm taking my f function, I'm going to go back to the beginning here. My f function is this, 3x squared minus x plus 4. And I'm going to put that in for what variable? In through the g function. Put it in for x. Okay. So I'm going to have 2 and then parentheses, this f function minus 1. That'll be a little bit easier to calculate. Let's go ahead and find that. 3x squared minus x plus 4. So we're putting that in for x. Again, let's just distribute that 2 and add any like terms that we have. So we have 6x squared minus 2x plus 8 minus 1. Which simplifies to 6x squared minus 2x plus 7. 8 minus 1 is 7. Okay, so we've really done a couple of different things today. We have added, subtracted, multiplied, and divided functions, and we've worked on composition of functions. One thing I want to go back to is if you're struggling to remember this, think about the pineapple pizza. That might help you. If it's f composite g, we're going to take our g function and put it into the f. We're taking our pineapple and putting it into the pizza. If it's g composite f, we're going to take our f function and put it in to the g. So we're going to take the pizza and put it into the pineapple. I have some practice problems for you guys out of your textbook. We're on page 413. I'm going to be very picky when we grade. You have to label your work. If you just give me an answer that's going to be incorrect today. I need you to label your work. If it's f composite g or g composite f, please label it. If you're adding your functions, please write f plus g of x. You have to show me that, or I'm going to mark it incorrect. Please label what is what. You may go ahead and get started. We do have a little bit of time. Let's utilize it.